Another technique that made it to my list of favorites is what I called a synthesis or a creation task. And a lot of the best students, they do this at the conclusion of their learning part so that they are really ready to tackle the mastery system. You know, at this level, what you're really doing is you're using the highest possible levels of thinking. And you should strive to get this far if you can, okay? Basically, the idea here is that you create an experiment or an idea that can help you explore or research a question that's based on the topic that you're studying. So on the first topic of the year, well, no, the first few topics of the year, we'll talk about the nature of science. I'll give you an extended example of how to do that. So I'm going to save that example for then. But basically, the basic format of this is that you start with a research question, is what you want to address, and then you transfer the research question into a problem statement, like the effect of blank on blank. So let's say, for example, you're studying about transpiration and how the water goes from the roots of the plants all the way to the leaves. And then you can say, I wonder if wind has any effect on that. So your question is the effect of wind on transpiration rates. And so you put the effect of wind on transpiration rates, and that already helps you find what would be the independent variable and the dependent variable of your study, or the thing that you manipulate and the thing that you're going to be measured, also called the response variable. All right? Then you also have to think about constants. What are other things that could affect the transpiration rate, which is not the wind? And all of these things will have to be things that you have to maintain constant in your experiment. All right? Then based on those things, you can then design an experimental group. Now, these experimental groups are going to be one or two groups which will receive different levels of the treatment, which is basically changing the independent variables. So let's say one group you have no wind, another group you have a little more wind, another group you have a little more wind. So those are the experimental groups because you're changing the independent variable for those groups, while all the constants will stay the same. You're going to keep the temperature the same. You're going to keep the intensity of the light the same, and things like that. The humidity of the air, all of that. So, and then you have the control group. Now, the control group is not the group that you don't do anything to. It's the group where you make sure that the independent variable does not change. So let's say, for example, the standard group will be the one that you compare to make sure that what you did was in fact what caused the outcome. So let's say, for example, this would be the one with no wind. So you can make sure that the wind was indeed what caused the outcome. Now, after you have those things identified, then you can form what is called a hypothesis, where you think that if I do this to the independent variable, then this will happen to the dependent variable. So, for example, if I increase the wind, then there will be more transpiration rate. That kind of a thing. It's a hypothesis. And of course, this will be based on your understanding that you've learned about what the effect of wind possibly could have been as you did your research about the problems. Now, once you do this, then you get ready to pretty much come up with a step-by-step procedure for your experiment, because you should know now how the independent variable should be changed. In this case, add or more wind. You should know how the dependent variable has to be measured. In this case, I have to measure the amount of transpiration, so maybe how much water goes away from a cup where the plant is like inside of. You should tell there's going to be a control group where there's no wind, a group there's going to be more wind. Maybe this one will have the fan at 1 setting, the second one will have the setting 2, and so forth. You also have to talk about all the things you're going to keep constant, the temperature, the humidity. We talked about that already. Things you have to do for safety. You're going to handle grass. You're going to handle the fan, electricity, water next to the electricity, all that stuff. Steps that you're going to take to maximize validity, such things as, the precision of experiment, the reliability, the accuracy. All of these things we talk about in more detail when we do the nature of science. But basically, you design an experiment and write about it. Then you create a full description about the experiment. You wouldn't believe how this task also is helpful, because it's an inquiry task. It's helping you use the knowledge that you gained and an actual method. And as we go throughout the year, this is going to be very important, especially in the advanced classes, to try to do. And so it's a great task to add to your, possibly, to your study session, so that you can get used to doing this. And then it will make it easier for you on level 5 when you actually have to do an experiment like this if you get this far. Now, you might even want to take it a step further, by the way. What you can do is you can come up with what you think the results would be. In other words, infer what you think would happen in the experiment. Or you can actually do the experiment and then come up, have that data and present that data and write a conclusion statement for it. So, and that's, you know, basically doing an experiment as part of your learning experience. And then only the advanced students get that far or do this kind of stuff. But it may be a great tool for those of you who love science. And so I wanted to put that out here.